Thank you very much, and good morning, everyone. I'm Jonathan Eyre. I'm a Senior Technical Fellow for Digital Twins at the AMRC, just for a correction. And Ali, do you want to introduce yourself as well?
Yeah, good morning, everyone. I'm Nicholl. I'm part of the founding team at IOTICS and was delighted to work with AMRC on this decentralized digital twin demonstrator.
Great. So this was a piece of work we did last year, and just sort of wanted to highlight some of the practices that we found and wanted to advocate for, really. So HySeed is a hydrogen innovation initiative that's been going over for over the past year now. And we were particularly looking at what we could do for a decentralized digital twin for the exchange and distribution of hydrogen, to really have a matter of weeks, really, to go, okay, we all agree it's a socio-technical challenge, but sometimes you need to show off the technology so they get it, they realise where they're going, to then start to address the cultural changes in the organisational structures of how we're going to move forward. So there was three main goals of the demonstrator. It was to, one, prove it was possible and prove how much was already possible. It was to, two, start to look at supply chain interaction, because that's going to be one of the more complicated things with regards to, it's not just energy now, it's how was that energy also produced? So was it produced by a nuclear power station, or was it produced by solar, or was it imported? Will actually start to be part of the decision making for the supply chain. And the Southwest in particular is a highly distributed thing where not much is needed in certain areas, and it's much more fragmented to be able to manage that information. And it's also then thirdly to prove out that a scalable architecture is possible with the baseline data models. Now, anyone who's heard Alex Luck speak about this, she is obviously running the National Digital Twin Programme, but she isn't building the National Digital Twin. She's very vocal about this herself. So we were looking at this from that sort of similar train of thought, but looking at what can we build up of all these different twins, to get site twins, to build regional twins, to look at how they could start to come together to form parts of these national capabilities as we move forward. So the approach, an engineer myself, is very much through and through a systems engineering approach that we took. So some people just say, oh, give me data, I'll spit it on a dashboard, and that'll give me some value. And until you ask, well, what are you doing it for? Why on earth are you doing it? And how are you actually going to implement it? Why are you spending your time? So this allows us to quantify what personas are in the ecosystem, what information do they need and why, and how should they be accessing it? So this gives the rigor and the backbone to go, these are the justifications for why the particular data is being used in this ecosystem. So we captured a lot more use cases than we've actually demonstrated. But again, we're talking weeks of work here, not months and large scale deployments of things, just to prove out what is already possible really easily. So we did have the customer engagement at Southwest. One of the big use cases there being Bristol Airport, of they're already making investments in hydrogen for the future aircraft. But it's a case of then looking at, okay, what does the ecosystem look around them? So we've got loads of diagrams like on the right. I'm not going into the details. You'll be all glad to hear. So, Ali, I believe this is yours.
Yeah. So what the AMRC team needed to do post those conversations with all the stakeholders was look at how do we take an approach and a format that enables us to look at a couple of different scenarios. So the sunny day scenario, as we've outlined here, and the rainy day scenario, in terms of the supply lines, the infrastructure, and what's required to work across a group. But importantly, how do we do that in a way that is those base data models, real base data models that are reflective of the actual infrastructure that will be required, i.e. one that is decentralized and doesn't have a single owner. So the concept and what was ultimately delivered was to take a series of separate organizations, usefully labeled supplier A, B, and C here, and as well as a demand side order and usage simulator, to start looking at how can we ensure self-sovereignty of each piece of domain across a private network initially, where they could order and supply information to each other using real data models, but simulated usage data. And importantly, doing that across a data access layer or an infrastructure piece that would enable them to retain ownership, structure models how they want, and deliver on usage. And we'll come on a little bit later to how they were doing the selective sharing. So if we move on to the next slide, please. The solution ultimately was to look at how can we bring together both that private network, but also have the ability both in the future and using the real underlying models to link into a public network of open spaces, the weather, the environment, etc., working across multiple domains. And what the AMRC team were able to do very rapidly was create these simulator pieces and indeed a web app, so that we aren't just creating data for data's sake, as Jonathan said, but actually creating real what if websites, web apps, and React dashboards for different users in different scenarios to deliver the solutions they need, and ultimately what the stakeholders were saying they wanted, which was simple interfaces that they could query. Jonathan?
Perfect. So this is also then just an example of that React website. So again, not here to say this is the world's better user experience of the data, but again, when you've got the semantics and the underlying understanding of the data sources, these things are quick to mock up and also quick to start to go, is this the experience that you want to have of the data sources? Ali, is there anything more you want to add on that, or are you going to wrap up towards the end of that one?
Yeah, I think the key piece here is to show that what we're looking at and what the AMRC team were able to rapidly do is use established processes with model-based systems in engineering, off-the-shelf technology, but to rapidly customize and deliver insights based on the semantic insights of the individual groups and pieces, which enable them to walk towards how we can ensure that we are leveraging the best information at the best time, and able to rapidly access the underlying information where permissions allow. And we can see some of that exploring the information on the next tab.
So as Ali mentioned, we all talk about linked data and the underpinning of the sort of W3 and whatever else. And it was that linking that we went then from the website back to the single source of truth. So back to this distributed data source of what can I access and what can I twin together. And then we've also got the ability in the platform to then go, right, what's happening for Solar Game? What's happening for these different things of what's publicly available as well? So that's kind of going back into the back end then, but seeing it and actually sort of touching the data as well of what you can do for that federation. That then leverages the extra sort of prediction queries we can do around the federation and different things we're trying to do there. But one of the key things that we're trying to do is about the controlled access. So security by design and all of that coming through then to go, right, you could have your full twin as an internal user, the client and the owner of the data, where you've got full visibility. But then permissions sort of give the ability to go, actually, if you start to have shadow twins or some sort of restriction of that data, we can just show you parts of it. And actually, for those keen-eyed amongst you, at the top right, you see 4 icons, but in the bottom right, you're only seeing 3. So actually, it's not just a case of what data you want to restrict. Do you even see it at all? Or could you even just start to request access because you understand the data model behind it all? So conscious of time, systems engineering for us was a really common way that we've been doing since the space race with NASA to go, this is how we design systems. This is tried and tested engineering and a really good way of articulating use cases. And the technology, okay, IOTICS being one, but there's plenty out there of what's commercially available. If you want to distribute and federate, there's loads out there. If you want to look at centralizing, unified namespace is an open concept for how you centralize, for myself in engineering, shop floor management. And once you've got the semantics there, you've got that consistent querying structure through ontologies that I've mentioned tail end of last year. There's some great talks about that, and also the foundational data models to go, this is how we can start to interrogate those data sets. So for myself, start small, start with the use cases. And this is, I think fairly sure, it was 2 or 3 sprints worth of effort just to knock this together to go, look, this is possible. What's stopping you within your own organizations? Ali, any final reflections?
I think that's the key takeaway for me. The point isn't that this was 2 sprints, and then if we were going to do this for real, we'd start again with a blank piece of paper. This is an iterative, evolving piece where each of those real models can be used, and we can continue to bring in the consistency of the ontologies and expand out the foundational data models as we work across different segments. And it's important that we see this in the context of what's happening in the wider community of everyone on this call. So things like the Apollo protocol, looking at how we can do those cross-sectoral pieces and how we can create commons between sectors to enable what is ultimately this kind of infrastructure's underlying ontological and foundational pieces. If we look at what was coming out of the Femby-Taylor review in terms of the cyber physical infrastructure, which I know that the CPC and the DT Hub is looking at, all of this is built around the same piece of saying the technology exists, the federation exists, the understanding exists, and we can composite this stuff together in weeks. There is absolutely nothing that should stop anyone on this call being able to stand stuff up within a month, deliver value within a quarter, and expand it to the scale that they need to deliver real sustainable change and energy transition. That's it for us.
Thank you much. back to Simon.
So our first question, please, to Ali and Jonathan is, what platform did you use to create the web interface?
That's the easy one. So it's split into two halves. So the database and the storage side is the IOTICS platform. The front-end service was a custom homebrew sort of React application as a framework.
So our next question is probably to all of our speakers, actually. Who should own infrastructure underlying connected digital twins? So, Anne-Marie, maybe you've got a thought on that first, and Jonathan, Ali, if you've got views as well.
I don't think there's a personal view. There won't be a one size fits all on the right. I would say this is part and parcel of the operating model. I don't think there's a one size fits all on this. I think it will depend on the specific characteristics of the project. That's my particular view, but I'm sure Ellie and Jonathan may have different views.
No, completely agree. And I think to give examples of that, if you are the Boeing and Airbuses of the world, you may own your own infrastructure and mandate that as part of the supply chain, you use our infrastructure. Whereas somebody else, if you're in a more collaborative environment, you might not trust any individual party to also be part of the party and also the infrastructure. So then you need somebody independent to host the environment to establish that data sharing infrastructure. So completely agree, very much fit for purpose and very much fit for the use case you're trying to do. Ali?
Well, so more agreement, unsurprisingly, considering all of our backgrounds. But I think that when we look at the models, what we've seen in the past is that kind of centralized ownership for Airbus or so on through things like Skywise and so on works really well right up until their supply chain bumps into someone else's supply chain, at which point you have two big dogs in the fight. So the truth is the fundamental infrastructure should be owned by those people that own the pieces of it. So they may choose a third party to do it on their behalf. But actually, that's the point of the decentralized federated common working environment and why these principles around trust frameworks are so important. I think if we look elsewhere across the community, the National Grid ESO virtual energy system, for example, is absolutely explicit that we need a national virtual energy system. They don't want to own it. They want a selection of different people to own it and be able to interoperate in a decentralized way through a trust framework that they may set some of the rules for, based on some of the principles that Sarah and Anna-Marie and others are working on. But fundamentally, the actual ownership, we should increasingly take ownership of our own pieces, even if our choice is ultimately, to Jonathan's point, to say to a third party, I am comfortable in this example that will use your secure cloud or common working environment or whatever else. But fundamentally, I think everything we're doing, if at some point someone says, oh yes, and Jeff will own it all, we're doomed to failure.
Thank you. Jonathan, Ali, in the demo you shared, what advantages does semantic/linked data have to application developers?
So the main thing was,
yeah, I'm deferring to John, otherwise this is a little bit incestuous.
So the main thing that you can start to do with the semantics is quantify the unknown unknowns and the known unknowns and kind of that whole quadrant. So if you start to specify, I have a position on the UK, well, great, but do you actually know it's a GPS location, or is it longitude, latitude specifics, or how are you actually working with it? So unit consistency and all those things. But you can also go, well, I can't visualize you because you haven't given me your location. So then you can quantify and start to move towards higher data quality because you know what you're missing. And that seems to be the massive issue, and one of the massive issues with, if I just give you a blob of JSON or XML, it takes a lot more to parse and process to understand what you're missing, and you've not got the relationships that you need otherwise. That starts with the advantage of the semantics. You can soon get into the weeds, so I'm probably going to pause there and move on, Simon. But by all means, Mark, we can always pick that up offline.